Hello, everyone. I'm Dan Alou, and I'm the CEO of the Computer History Museum. I hope everyone is well and safe today. I'm particularly excited to welcome you to the first public education event featuring the inaugural recipients of the Patrick J. McGovern Tech for Humanity Prize here at CHM. Today, we're featuring two changemakers who are examining and developing and applying technology to address challenges of our digital age to shape a better future. Our programs are made possible through the generosity of our members and donors, and today we need your help more than ever to sustain the museum in delivering on our mission, which is to decode technology for everyone, its computing past, the digital present, and the future impact on humanity. And here today to introduce the program, our partners and speakers is Marguerite Gong Hanguk, the executive lead for the McGovern Prize program and the VP of Innovation and Programming here at CHM. Marguerite?
Thanks so much, Daniel. I'm delighted to add my warm welcome to each of you for this special program. It's our first public event of the CHM Patrick J. McGovern Tech for Humanity Prize. It's very exciting. So let's begin with a brief introduction about the prize, purpose, people and partners, as Daniel said. As part of our commitment to Tech for Good, in January 2021, the museum launched the Patrick J. McGovern Tech for Humanity Prize. The focus, to celebrate, deepen the understanding of their work, and advance the impact of changemakers who are meeting challenges of our time to shape a better future. The prize program fosters a global community committed to Tech for Good. It advances work for social impact, highlights role models, and inspires the next generation of innovators. The prize is in honor of the legacy of Patrick J. McGovern, an IT visionary, successful entrepreneur, technology journalism pioneer, global trailblazer, and humanitarian. He was founder of market intelligence firm IDC, and IDG, a global media company with more than 300 print publications, including Computer World, Macworld, PC World, and many others. We're grateful to leaders at both IDC and IDG for helping spread the word around the world about the prize. And here at the museum, Pat had a very special role. In 1982, when the first incarnation of CHM was established as a computer museum in Boston, Pat was an original member of the board, a generous supporter, and an active participant in museum events. For the prize program, we are very grateful to have as champion Laurie Hart McGovern, co-founder and chair of the McGovern Institute for Brain Research at MIT, and a remarkable CHM trustee. Our partner is the Patrick J. McGovern Foundation, a global 21st century philanthropy committed to bridging the frontiers of AI, data science, and social impact. All of this is made possible by the generous support and partnership of the McGovern Foundation. So it's now my pleasure to introduce the chair of the board, Pat McGovern. Pat?
Great. Well, thank you, Marguerite. And thank you all for being here. It's such a pleasure to be here today and welcome the first Tech for Humanity Changemakers, Mercy and Michael. You know, this award is a special one for us at the Patrick J. McGovern Foundation. This award is in memory of my father, Pat McGovern, a tech industry pioneer, visionary businessman, and dedicated humanitarian. From his early days, Pat McGovern was a change maker. And over the span of his career, he helped to define an entire era of technology advancement. When my father was a college student at MIT in the 1950s, he had the foresight to understand that computers were going to transform our world in ways that we could hardly imagine. He recognized that consumers, business leaders, and technologists could be hungry for reliable data, information, and analysis on the emerging tech sector. So combining his technology expertise, creative talents, and business acumen, he founded IDG, International Data Group, a global technology publishing company. He started the firm when he was only 27 years old. What emerged from his humble start was a new sector of publishing, computer tech magazines. He launched titles that you all probably know: Computer World, Macworld, InfoWorld, PC World, and you might even recognize some yellow books that were in the bookstores. Over time, Computer World, or IDG actually, grew to 90 countries, 300 print publications, 450 websites, and 750 annual events. As remarkable as my father's accomplishments were, so too was his incredible optimism, charisma, and generosity. My father cared about people, and it showed in how he and his company gave back to the world. During his lifetime, he and his wife, Lori McGovern, championed the advancement of neuroscientific research to understand the brain and apply that knowledge to help people with brain disorders. He was also a benefactor of many organizations. As Marguerite mentioned earlier, he was an original member of the Computer History Museum Board, alongside museum co-founders Gordon and Gwen Bell, and other IT pioneers such as Bob Noyce, co-founder of Intel. It is in this spirit of optimism and belief that technology can be force for good that we celebrate today. Throughout his career, my father continuously found ways to support the work of exceptional individuals. He believed people, not institutions, can change the world. The Tech for Humanity Changemakers Award was created to honor this legacy of uplifting those whose talent, brilliance, and passion are advancing technology in service to humanity. As a member of the award judging committee, I can tell you that we had a large inflow of amazing applicants, each of them doing work, important work. Michael and Mercy inspired us with their innovation and tremendous potential to do good. Mercy, a biomedical engineer, is applying technology to close the gap on global health inequities. And in his work at Stanford, Michael is developing a jury-based approach to AI that will reduce bias in technology. I know my father would be thrilled to see the work that our first year of Changemakers have accomplished. Thank you, Mercy and Michael, for all that you do and all you will do in the future to create a thriving, equitable, and sustainable future for us all. And with that, I will give the microphone back to Marguerite.
Thank you so much, Pat. It's wonderful to honor the legacy of your father and to, as you said, continue this legacy of people who will change the world. It's a pleasure to work with you, Vilas, and the Foundation's team on the prize. On behalf of CHM, I'd like to also thank our selection committee, including Pat and a dozen others, remarkable individuals from the US, Asia, and Europe who have made contributions in technology, business, media, and the arts, academia, and public service. I'm pleased that 3 will be part of today's program. I'd like you to know that in April this year, thanks to the efforts of the selection committee and the prize program team here at the museum, we announced the inaugural prize recipients. Pat has mentioned the 2 Changemakers, and in addition, we announced the inaugural luminary for a lifetime of achievement, Saul Khan, for his extraordinary impact, expanding access to learning worldwide and providing free online education to anyone. Khan Academy has reached more than 120 million registered users in 190 countries. So we will be celebrating in a formal ceremony these 3 recipients in a prize program next spring, postponed due to the pandemic conditions. But today, we're thrilled to feature these inaugural Patrick J. McGovern Tech for Humanity Changemakers. As is tradition, I'll introduce our first Changemaker using 5 numbers. She's a Schmidt postdoctoral fellow at MIT and co-founder of Gap Health Technologies and co-founder and CTO of Cala Health Foundation. She holds a bachelor's degree in biomedical engineering from the University of Rochester, a PhD in biomedical engineering, and a certificate in global health from Duke University. Here are her 5 numbers. 2 companies founded, 18 awards, fellowships, and scholarships received, 130 million, the approximate number of people in sub-Saharan Africa with top non-communicable diseases, including cardiovascular disease, diabetes, and cancer. 150, the number of years of speculum has had no significant changes, despite the fact that 500,000 women are diagnosed with cervical cancer each year. And last, but certainly not least, one new mother of 1 precious little baby. Welcome, Mercy. Congratulations on receiving the Changemaker Prize and on the birth of your son. We look forward to learning about you and your Changemaker project.
Hello, my name is Ms. Nyamewaa Asiedu. I am a Schmidt Science Postdoctoral Research Fellow at MIT. I'm also co-founder of 2 companies which are also recipients of the CHM McGovern Prize, the Cala Health Foundation and Gap Health Technologies, and I'll talk about those a bit more. So just a little bit of background on me. I come from Ghana, a small but powerful country in West Africa, and I grew up here until I finished high school, after which I received a full scholarship through the Zawadi Africa Education Fund to come and study in the United States. This led me to the University of Rochester, where I majored in biomedical engineering. And here, my passion for using engineering to solve global health problems was ignited. What you see here is on the left is that technology, when used for healthcare, has potential to really have a profound impact. But unfortunately, technology is typically created for high income settings or most of the time developed countries such as the United States and countries in Europe. And unfortunately, when these technologies are simply transplanted into low and middle income countries, due to issues and constraints around maintenance, around internet and power issues, and also human resources, along the line, these tools, instead of being impactful, end up in a rubbish heap, as shown on the right side. So I wanted to figure out how to create and develop technology in a way that has these constraints of developing or low and middle income countries in mind and can truly make an impact. And this led me to do a PhD in biomedical engineering at Duke University with a focus on developing tools for global health settings. After my PhD, I received a fellowship to the Massachusetts Institute of Technology, where I currently work on using novel machine learning techniques to improve ultrasound imaging for low-cost portable ultrasound devices. So my vision overall when it comes to engineering and global health is to, first of all, democratize health, create tools with the context of developing countries in mind, and make sure that they really have the impact they are meant to and are readily accessible. And the second is representative data. As machine learning takes hold and becomes a bigger presence in healthcare and could potentially have a bigger impact in healthcare, it is really imperative that data used for training these models is representative of everywhere that they will be used, and that includes sub-Saharan African regions. And I want to ensure that people who might not typically be represented in these data sets are. And this brings me to my CHM McGovern Changemaker prize project, reflected through two companies I'm working with, and that's Gap Health, where we seek to create smarter healthcare for chronic disease management, and Color Health, where we seek to reimagine gynecology. So I'll talk a bit first about Gap Health, which I co-founded with my wonderful partner Bintu Kaira, who is from Gambia. And our mission is to help patients take ownership of their health, bridge the gap between patients and clinics, and learn from every patient's journey along the way. So this is a really personal project for us. The lady shown here was my partner Bintu's mother, who passed away in 2014 from complications of unmanaged diabetes. My mother currently struggles with her diabetes management, and my maternal grandmother, who I never got to see, passed away at an early stage from complications of diabetes. Diabetes, as well as other chronic health conditions, are on the rise in sub-Saharan Africa. It's expected that between now and 2045, diabetes will increase by 147% in the region. Over 60% of people with diabetes in the region are undiagnosed and are not managing their care. And this resulted in an urgent call for action by the WHO and the Lancet on diabetes. And this trend is not just true for diabetes, but true for non-communicable diseases in general. What you can see here is a graph that shows that between 1990s and now, non-communicable diseases in the sub-Saharan African region has drastically increased. And the top three NCDs, which are cardiovascular cancers and diabetes, are showing an upward trend. It is imperative that these be curbed and addressed for the region to achieve the Sustainable Development Goals, particularly the Good Health and Well-being Goal. So the gaps in chronic healthcare that we have identified in Gap Health include the lack of quality data from sub-Saharan Africa to understand manifestations and predict trends. Most guidelines are based on data from developed countries like the United States and countries in Europe, which may not necessarily correspond to what's happening on the ground in the region. There's also the issue of the broken care pipeline in linkages between patients and specialist care, which we want to fix. And finally, access to consistent medication, with lack of access rates being as high as 75%. When it comes to data, what you see here is how most clinics in the region store their health records in stacks of paper files that are really difficult to access. These can easily be destroyed or lost, and also make it really hard to do any research that provides additional information or to bring in machine learning aspects to understand the data for improved healthcare. So our solution is to create a very simple, accessible way for patients to store and manage their data, own that data, and also reach specialist care through mobile phones. Mobile phones can be found almost in every corner of sub-Saharan Africa just now, and we want to capitalize on that to make sure patients are getting the health they deserve, the healthcare they deserve. And part of this includes health tracking, where we have a low-cost, secure, encrypted way for patients to store and track their health data, and use this data with patients' permission to generate data insights with research and AI, and connect them with specialist care as needed through virtual and in-person services. So this is a working prototype of our practical and easy to use platform, which has a provider interface where doctors, community health workers, and nurses can easily sign up and be verified, and a patient interface where patients can reach providers on the platform and store their data, and an admin panel for managing the process. Our long-term impact includes the current phase we are in, which is simply to provide the access to health providers and a simple medical data storage through data form entry. And then if down the line, take this data, organize it, and in a way that can be easily used for research, and label and annotate it in a manner that can readily be used for AI. And in phase 3, use this to either in collaboration with governmental or agencies or research institutions to generate data insights and patient recommendations. What we've been able to achieve with the McGovern Changemaker Prize is to take the prototype we have and commence on pilot studies with 2 to 3 clinics in Ghana and Gambia. Any feedback from these clinics, we've been able to bring on a full-time software developer who is implementing the feedback as we go along and taking us to the next stage for a full launch of the product. The next thing I want to talk about is the second project, which was given to the Color Health Foundation, which I'm a co-founder and CTO of. And here we develop innovative point-of-care technologies to democratize access to cervical cancer diagnosis for global women's health. And a little bit of background on cervical cancer. There's 500,000 new cases per year with a 55% mortality, and over 85% of deaths from cervical cancer occur in low and middle income countries because most women go unscreened. But cervical cancer is slow growing and extremely preventable and treatable if found early. So we have developed low cost tools for early cervical cancer screening and diagnosis. And the first part of this package are 2 high quality imaging tools for provider and self-imaging, a communication platform based on a mobile app that can be used for patient storage, data storage, and tracking, and decision-making algorithms that take images taken with technology and provides a risk assessment. And this helps to reduce subjectivity and also helps to reduce the need for experts on the field. So the pocket colposcope, which is kind of the first in line tool that we are bringing to market, is FDA cleared. We've shown that it works as well as a $20,000 device used at Duke University, and we've shown that with various clinical images, and you can see that in the images of the cervix shown on the slide. When we developed the pocket colposcope, we realized that traditional colposcopy requires the insertion of a speculum to be able to expand the entire vaginal canal for visualization from outside the body, either with the naked eye or with a colposcope. But since we could insert this device, we thought, why don't we create a way, one, to visualize it without the speculum, and two, to have the patient use it themselves. And just to give you some context, this is an image of the speculum. It's a device that's quite painful to use and has seen no significant change in over 150 years despite advances in technology. So this led to development of the colorscope, which was the focus of my PhD research. And it's a self-use, low-cost portable device that allows speculum-free imaging of the cervix. And here you see a patient actually inserting the device and manipulating it to see her cervix for self-imaging. And both the colorscope and the pocket colposcope have been tested in 10 countries globally, including Ghana, and have generated highly positive user feedback compared to traditional means of screening. During my PhD research, we took images with these devices and generated and extracted texture and color information to put into a support vector machine and logistic regression model to automatically generate risk assessment, which can be shown on this ROC curve, and generated performances above 80% accuracy and actually better than expert providers. And what we are doing with the CHM award is to take this one step further. As we bring in additional data, we want to move towards novel machine learning techniques like convolutional neural networks and use that to improve our model and generalize the model so it works seamlessly across different clinics, and then incorporate that into our mobile application. Thank you.
Thank you so much, Mercy. It's wonderful. Been wonderful to interact with you during the past 6 months, and today to share with our audiences that your passion for your work and to hear about the ways that the Changemaker prize funding has helped advance your areas of impact. We'll have you return for question and answer a little bit later in the program. By the way, if you'd like to learn more about the prize program and recipients, please see the McGovern Tech for Humanity prize portion of our CHM website, including brand new videos of our Changemakers, which we released today. Next, we'll hear a presentation by our other inaugural Patrick J. McGovern Tech for Humanity Changemaker. He's an associate professor of computer science at Stanford University, where he's a member of the Human-Computer Interaction Group. He holds a bachelor's degree in symbolic systems from Stanford, as well as a master's degree and a PhD in computer science from MIT. Here are his 5 numbers. 2008, the year he started working on social computing design. 4 billion people worldwide who now use social media. 12 PhD students so far. 9 departments at Stanford whose faculty he's collaborated with so far, and 158,000 views on a TikTok video from a student saying that he looks a little bit like an older version of the actor Tom Holland. Let's give a very warm welcome to Michael. Michael, it's been wonderful to have you part of our community this year. We look forward to hearing about your Changemaker project and your work.
So my Changemaker project is thinking about how we design the artificial intelligence or AI systems that are diffused throughout our society. Since essentially the original development of AIs, we've often sort of created them in what you might think of as a hermetically sealed chamber. The AI is in a box, it's in a room, and it gets inputs, and then it produces outputs based on what it's been trained or programmed to do. But AIs are embedded in a social context. And one of the things that we've learned really valuably over the last few years is that AIs are being used to support people. And they're run with, for, and sometimes against people. So who is in the room here? What are we using the AI to achieve? Who's benefiting? Who's being harmed by this? Are all questions that we've learned a lot about how to ask and how to be more reflective on. But this isn't the only question that arises when AIs are placed in societal and social contexts. Another one is, well, whose data is this anyway? Which individuals are being used to train these algorithms? Whose labels are they being trained to imitate? But speaking as someone who travels in the data annotation circles, we know a lot less about what to do about this. And this kind of question ends up being sort of an animating force for our Changemaker project. Because not only do we have to care about the inputs and the outputs and their embeddedness in a social context, the AIs themselves are influencing platforms like Facebook, Twitter, Wikipedia, these platforms, even Zoom, that are changing how we interact with each other. Right? So we have AIs embedded in platforms that are influencing human-human interaction. And we have to understand how to do this better. So AIs are embedded in this really complex dance that we're involved in as social creatures. And yet somehow what we do with them ends up just still being very simplified. It's acting as if the social interaction is totally absent. An AI in a hermetically sealed room. And our Changemaker project asks how we can do better, how we can design artificial intelligence to better navigate these kinds of issues. And specifically, we're focused on societal disagreement. This is a big deal, and I'm going to try to convey to you why. These platforms like Facebook, Twitter, Pinterest, TikTok, social media, and many others are using artificial intelligence algorithms to try and do things like detect toxic content, like harassment online, misinformation, disinformation, to perform moderation, to sort of keep the spaces as ones that we really want to engage in. And the way that they're built and developed is through essentially a majority vote. The typical approach is that we have an input and we ask a series of annotators to label, is this thing a positive or a negative class? And the AI is expected to learn, to predict, would they have said positive or negative on something that's a new input. So in this example, we might have 3 people who said this ought to be labeled gray, 2 people who said this ought to be labeled red. We typically use a majority vote and flatten this into a ground truth label, as it's called, that just is gray. It says this thing is gray. You should predict gray, and this is okay for a lot of tasks for which machine learning really and AI came of age. Image classification, a classic example. Is this a dog or a cat? Now, it would be a really, really weird-looking cat, so I'm guessing that most of us are going to agree that this is a dog. In contrast, in these social media applications where I tend to spend a lot of my time thinking, the classifications are much more muddy, where people will disagree about this. For example, is this comment on the screen toxic? It's making some pretty aggressive comments. It's really maybe questionable, and it turns out that people really disagree about whether this comment crosses the line and ought to be removed. Should it be classified as toxic or not? And our approach that machine learning has used of aggregating through majority vote ends up having the effect of silencing minoritized groups. Because when this disagreement is irreconcilable, who you sample before that majority vote really matters. We typically don't think about it. We just go grab people, we ask them to label it. So if 3 said non-toxic, and then 2 said toxic, well, we'll end up non-toxic. And the reason that this is problematic is that minoritized groups are often the ones that say are subjected to harassment, that have the lived experience of getting toxic behaviors flung at them, but then they're overridden by the majority vote. And so their voices are basically silenced. And what ends up happening here is that the artificial intelligence algorithm learns to predict not toxic, ignoring exactly the people maybe who we should be listening to. And at best, it maybe learns to predict some distribution, but that distribution doesn't tell us who's being harmed. Disagreement is everywhere. In fact, in a common data set that we use in our work, if we look at all of the things that are labeled as toxic, on average about 40% of people disagree. So even on things that are in a particular class, the toxic or the challenging, the problematic class, there's a lot of disagreement on these kinds of labels. That's again very different than a dog or cat scenario that AI was largely brought up in. So we need to rethink how we deal with classifiers in these kinds of situations. It means that they look way more highly performant than they may actually be when they get launched in front of real people. So problems that look like they might be solved really aren't. So this gray bar, 0.95 ROC AUC, only goes up to 1. You can't do much better this is for a task that's this exact same toxicity classification task. It looks great, but when we start to actually account for the fact that people are disagreeing, and you say what percentage of people would actually agree with these classifications, not just what percentage of the ground truth does it agree with, it goes way down. And in fact, no algorithm can do much better than this, we're able to prove. So what are we going to do? This is the topic of our Changemaker project around what we call jury learning. Can we reshape and re-architect these machine learning approaches to do better, to just take a different metaphor, a different approach, and maintain the benefits of machine learning, but also do better in these situations where we have disagreement? So instead of silencing these voices of underrepresented groups through the aggregation process, we want the developer to be explicit, to say, well, whose voices should be determining this algorithm's behavior and in what proportion? Lay it out. In the traditional classifier, the picture looks like this, right? Where you take the input, you've got these 5 people who or 3 to 5 that you've sampled randomly. You don't know who they are or why they believe it this way, but you do the majority vote. And then the algorithm takes all these ground truth labels and learns to predict non-toxic on this item and on items that look like it. In jury learning, instead of randomly sampling, you've explicitly articulated the set of people who you want to pay attention to. So this might be, for example, in a toxicity case, we might want to define a jury that more heavily represents groups that have been targets of harassment: women, Black individuals in the case of Twitter and elsewhere. So we've now articulated a group of, say, 12, could be any number, but I'll use 12 of these examples, individuals whose voices, whose predictions should be used and weighted. So in jury learning, we get this input, this thing that people disagree with, and now we've also articulated our jury. Now, what the AI is going to do is not predict a single ground truth. It's going to learn to predict what every member of this jury, these individuals who were in the training data set, would say. So here, instead of 1 response, we get 12. And those 12 then become a jury decision that, say, vote 7 to 5, this item is seen as toxic. So the output of a jury learning system might be something like this. It might say, instead of toxic or not toxic, it might say something like, well, for this jury, it's 50% men, 50% women, it's split evenly across a number of different demographic groups. 56% of them agree that this comment is toxic. And this ends up meaning that we have to rethink a lot of our assumptions about how machine learning works or ought to work. So instead of training a classifier to predict a single outcome or to predict a distribution of outcomes, we ought to be training our classifiers to predict what a bunch of different individuals are thinking. And then we can aggregate based on our values how those individuals' opinions should result in a decision. So what we end up doing is building a machine learning classifier pipeline that takes all the advances from modern deep learning that have made machine learning so performant in the last decade, and then fusing it with insights from recommender systems. You can think of this intuitively as saying, like, well, what if Netflix could actually predict what I would think of a movie before anyone's ever seen the movie? It's just fed the script of the movie. Could it predict my opinion of the movie? And this ends up creating all sorts of interesting questions on the machine learning modeling side about how we take things like text inputs on completely unseen examples and then merge that with insights from recommender systems, where it starts to learn, groups of individuals and how it can borrow information from other individuals to predict what a single individual might think. Now, jury learning, we think, has a lot of benefits if we can get this to work well and diffuse it into society. One is, we think it's really, really important that in many situations, we should make those values explicit by reflecting the stakeholders and even maybe just publishing publicly, well, who's the jury for this machine learning system? Which individuals are we listening to in what proportion as this AI is making decisions? And maybe even in what situations? In what situations does the jury look like this? In what situations does the jury look like that? You can then turn this over to participatory democratic approaches. Communities can decide for themselves what they think the AI should be doing, and so on. There are also interpretability benefits. Now, AI has often been criticized, despite being really powerful, that we just don't know, it can't explain what's going on. And there are some benefits here, like jury composition. You don't have to have a PhD in computer science to say, here's what I think the composition of this jury should look like. And you can also interpret the outcome. You can say it's something like, well, how many jurors were for or against this? It's not some confidence interval. It's literally just a jury vote, so to speak. You can also visualize dissent. In a traditional jury, you run it once. But with a jury learning, because all of the jurors, we're picking jurors randomly out of the pool, the set of individuals who you said might be relevant, we can then run a series of these and then visualize the set of outcomes. Well, how often did the outcome maybe would have flipped? What's the median outcome? How big's the spread? Is this a really contentious case or not? Now, we have some early evidence that this actually ends up resonating with individuals and changing how AIs actually work. So we went out and recruited a bunch of moderators for online social media platforms and asked them to author juries for an AI that would aid them with a moderation task. And we wanted to measure two things. We wanted to know whether the resulting juries represented more diverse opinions than the training data behind this current state-of-the-art classifiers, which, by the way, a major data set that's used is like 74% white. It looks a lot like me. And we were wondering whether maybe we would end up with something a bit more diverse, we hoped. And second, we were looking at downstream, does this change in the jury composition lead to changes in the actual decisions that these AIs make? Do we wind up with different outcomes? So one thing we saw was that, yeah, there was a large increase in the diversity of the voices that were guiding the AI's decisions here. The red bars on this graph are the proportions of individuals in the training data set. If we just through this quote unquote random sample, which as you can tell is not very representative in these data sets, there's a lot of white individuals, and what ends up happening is that these blue bars showing the other groups and how much they're represented are much higher than they are in the baseline data set. So simply giving people the power to articulate these things, they end up articulating much more diverse juries than you might otherwise wind up with, going from 74% white on average, for example, to something closer to about 25%. And these juries that they articulated then had downstream impacts. It changed the outcomes. It changed about 14% of classifications. Now, given that a lot of publishable improvements in this space are like, a few predictions changed here and there, it's 5% different. 14% of classifications changing is a pretty big number. And indeed, the comments that we saw that were the most likely to change were the ones that were most divisive. In practice, these ones that are really divisive end up sort of being really important. The people interpret the platform's effective policy as being what these AIs do. So it's really these edge cases that are changing, and those edge cases that are changing in ways that are more aligned, hopefully, with the values of the individuals who are creating them. Now, we're working now on creating a website where people can go and explore jury learning. They can compare it to a state-of-the-art classifier, articulate a few different kinds of juries, see the differences in how and what the outcomes look like. We want people to really engage with this. We're also hoping to open source the code quite soon so that companies, organizations, civil society organizations can all start implementing these kinds of techniques, and hopefully we can start to diffuse it. So behind a lot of this is my interest in how we work together to get things done. Whether we're seeking to have fun, maybe we're trying to work together like a team or an organization. There are as many different ways we could sort of design that interaction as there are people in the room. You're going to have a ton of different opinions about how to do it. And unfortunately, what the behavioral science has demonstrated is that we're not so good at doing those designs. The things that we would naturally think would work tend to kind of not work. And so increasingly we're in the situation where, if you want my opinion on it, where it used to be people would say, oh, well, we need better, more skills, people need more training. I don't think that's really often the case as often anymore. And now we're in a situation where these failures to achieve those goals, they're not because we don't have the right skills or the right people in the room, it's because we weren't able to get ourselves together to get it done. We weren't able to orchestrate our social interactions in a way that is the most effective or productive. But as a technologist, as a computer scientist, and as a designer, the thing that really gets me going is that these interactions are being increasingly mediated by technology. So whether that's on Facebook or Zoom, or again, Wikipedia, or whatever it would be, technology has the opportunity to sort of shift the furniture around. And by designing it, we can change how those social interactions work. We can help groups work together in the ways that they want to work together. And I think we can do better than the platforms that we have today. Imagine what might that future look like? What's even beyond what's the gig work platforms that are more pro-social, running hundreds of parallel experiments all together at the same time, creating fundamentally new algorithms by taking tens or hundreds of voices and minds and working together. Can we coordinate that kind of insight? My group collaboratively with folks at UC San Diego, UC Berkeley, and workers in online marketplaces started also creating essentially the first socio-technical infrastructure, the first platforms to allow online workers to organize. Thinking about, well, we have all these new modes of production, new ways that things can happen. Can we also envision what the future for work and workers might look like? Mozilla actually used this technique to run basically a design hackathon, an accessibility design drive to brainstorm ideas to make their Firefox browser more broadly accessible. We're also interested in how we can create more democratic and participatory governance online. With a collaborator at the University of Washington, we've been building Policy Kit, looking at ways in which communities can author for themselves, say, democratic governance. How do we make decisions? How do we even decide who's in charge here? These kinds of approaches haven't even been possible, but maybe by creating infrastructure, we can enable these communities to maybe shift out of some of the more sort of moderator admin style defaults into more participatory models. So that's really what my vision is around how we use technology and design to create more pro-social outcomes for the world around us. I have to thank a huge raft of really amazing PhD students, faculty, collaborators, and supporters, of course, including the Computer History Museum, the Patrick J. McGovern Foundation for supporting all of our work and all of these ideas that we've been able to pursue recently. So I really look forward to seeing this take flight, and just thank you.
Well, thank you, Michael. It's really exciting to see our Changemaker project on jury-based algorithms moving forward in such promising ways. Well, now it's time to open the program for comments and questions. Here to lead this conversation as moderator is Paul Sappho, who also serves as chair of our McGovern Prize Selection Committee. Paul's a Silicon Valley-based forecaster who studies the dynamics of large-scale long-term tech change and its impact on business and society. He also teaches at Stanford, where he's an adjunct professor in the School of Engineering. It's wonderful to work with you, Paul, as chair of the committee, and I want to thank you so much for leading this part of the program, including introducing two selection committee members who will kick off our comments and questions to Mercy and Michael. Over to you, Paul.
Thanks, Marguerite. It's wonderful to be here, and it's just so exciting to honor our two recipients today and hear more about their work. And so now this is the part where we're going to open this up to public discussion. Before I go any further, I encourage everybody listening, please send in your questions. We have folks who are sifting and looking at them, and I'm looking at them as well. And as a conversation starter to get things going, we have two of our committee members on the call participating. The first is Esther Dyson. She, like our other committee member, really needs no introduction. Esther has been an entrepreneur in the business. She's an investor and a philanthropist, but above all, is someone I've known for a very long time. She is one of the deepest thinkers reflecting on what's going on in Silicon Valley and in the tech sector, and someone I regularly turn to when I'm trying to figure something out. So she's just absolutely perfect for this. I'll also introduce Ed Catmull, who'll be following her. Esther is going to open with a question to Mercy. Then we'll go to Ed Catmull, who's recorded a comment. And Ed, of course, is the co-founder of Pixar. He was head of Walt Disney Studios. He's won Academy Awards and basically has made all of our lives so much happier with his videos. But now to Esther to have a quick conversation with Mercy. Take it away, Esther.
Hi, everybody. I'm apologizing slightly for my background, but not totally. I'm on site here in Muskegon, where we're working to help Muskegon, Michigan become a healthier community. And it's kind of with that context that I would love to ask Mercy a couple of questions. The first of which is, Mercy, just talk a little bit about your long-term vision. You're starting with diabetes and cervical cancer, which are two big problems, but I know you think even beyond that. So maybe you can just take it away.
Hi, Asa. Nice to see you again, and thanks.
Likewise.
So I think for me, long term, it's really about how can we really use what we know with technology to bridge health disparities. So I think I've been motivated by this because of, again, what I've seen growing up, and I had family members who I felt, passed away from extremely preventable causes, particularly in the areas of diagnostics. And, when I came to the US, I realized there was so much in terms of infrastructure and technology that was being used to prevent these, diseases from killing people. And it just struck me, like, why does this not exist everywhere? And I realized it doesn't exist everywhere because of the limitations I mentioned in the talk. So I really want to find ways that we can make technology that has people who are usually on the outskirts of community in mind, and people who we don't usually think about in mind. Medical tech companies create technology most of the time with the essence of making a profit, right? So of course it doesn't target someone who can't afford it. So that's kind of where I'm coming from. Can we create technologies that target people in underserved areas, not just in sub-Saharan Africa, but even the United States where I live?
Yeah, sorry about the. So talk a little bit about Africa in particular, those clinics. They play a huge role in people's health, but they themselves are underfinanced, and they need cheaper technology. But how do you interact with them? Are they your major route to people, or are you planning to go direct using social media, or just talk a little bit about the reality on the ground, which so much better than most of the people watching this?
Yeah. So I guess the reality differs for the different projects that I talked about. So for the Color Health Foundation, from the very start, we work with clinics and around the world. So the project actually came about when my professor, who I worked as a PhD student under, was invited to Tanzania by a doctor to look at the state of cervical cancer at KCMC and how late women were being diagnosed. So the idea for that problem actually did come from a clinic, and we have worked extensively with hospitals and clinics around the world to develop and test their products. And so we are reaching patients through the clinics to better screen for healthcare. And for Gap Health, I think it's the same, a similar approach that we are doing. So we are going through clinics who are serving patients, and then using providers, nurses, and community health workers as a way to approach patients as a first step. And then along the line, really reach patients through
And I mean, as a woman, I think the Caloscope should be for every woman, not just, it's such obvious technology. And talk a little bit about what you might do with the data de-identified, so that African governments can understand the situation in their own countries better.
Yeah, so I'm currently working with my postdoc at MIT, working on AI, and I was in a lab that was working on breast cancer imaging with mammography, and we're looking to make it more diverse. And I was like, okay, let me find some clinics in Ghana, some, Nigeria, Kenya, and see if we can have representative data. And it was along the line that I realized it was very difficult to get data, because I approached clinics in Ghana. The top 2 hospitals in Ghana told me their mammogram machines were not working for 5 years. And and the process for screening was different from the process for screening in the US. So it was palpation. So that means we can't get mammograms from these clinics. Similar case in some clinics I approached in Nigeria, and in Kenya, it just wasn't the way that screening was done. So I think that led me to think, first of all, how is data collected in these countries? What are the screening methods that are used? What are the data collection methods? How is the data stored? And data is stored usually on paper. EHRs, electronic health records, is something that is up and coming in some of the tertiary institutions, but it's not the case. It's not the case for small and middle sized clinics. So as a patient, you go from a small middle-sized clinic and you go to a tertiary institution, and they know nothing about your history. Yeah. So we really want to bridge that, provide the small and middle enterprises, patients who go there with their data records. It's right there on their phone. They go anywhere and it's there. And then we use that data with patients' permission, of course, to put them in formats that can be used for machine learning, and have people who are represented by those countries label the data. Because as Michael was saying, the labelers also have influences on how the algorithm performs. So that's really what we want to do long term, and then work with the government agencies too.
And I just have to say, that picture of all those folders of paper was horrifying. Hilarious and horrifying.
Yeah.
And so you personally, do you want to stay in the US, move to Africa? What's your mission is clear. What's your personal role in that mission?
Yeah, so I think my current family is in the US at the moment. And so I really see my trajectory as really moving back and forth between South Africa and the US, and building it there. So I would like to see myself half-time back home and half-time here.
Mm-hmm. And do you want to grow a large company, or do you want to become like the chief visionary and have someone else do the boring part? Or
I'm not sure yet. As of now, we want this company, Gap Health, to be one of the largest mobile digital health companies in sub-Saharan Africa. Yep, but you never know what will happen down the line.
Yeah. And what about your co-founder, Bai? Where is she living and what's she up to?
Yep, so Bai is actually a chemical engineer. She, same story as me, came from Gambia to the US to pursue education, and has always wanted to work in the space of medtech to improve healthcare. So she's currently she works in a potash mining company in I cannot pronounce the name, Saskatchewan in Canada.
Whatever.
Yeah, but yeah, we are both working really hard on this.
Well, I hope that the McGovern Prize helps her to maybe do this full time.
Yes,
She's got to, I assume she cares more about people than potash.
she does. She does. I wouldn't tell her her company that, but yeah.
Yeah. And your baby, has it made you lean into the mission more, or what? It's clearly going to change your life.
Yeah, I think outside of the sleepless nights, there's definitely been a lot more thought-provoking things that the pregnancy and childbirth actually had me reflect on. I had always thought, I had done a previous project on maternal mortality in the United States, which, we always think of, I had always thought of maternal mortality in developing countries. And that project really had me realize the disparities between minorities in the United States and death rates, and not just in maternity, but also in cervical cancer. So going through the system, I think, helped me learn a lot about why it's the case in the United States. And there's definitely room for improvement right here.
Right. I'm seeing there's some messages from the host, so I don't know if my time is up.
Esther, you can keep going.
Oh, okay. Honestly, Mercy, I would love to talk with you about what we're doing in the Wellville communities, because maternal health, it's kind of key to everything, because it basically helps create a resilient childhood, or lasting after effects. And maybe you can talk just a little bit about some of the impacts of what you just described.
Yeah. So I think, like, maternal health without a mother and the family, when I looked at this in developing countries and in developed countries as well, it really affects the growth and well-being of a child. So there's a saying in Ghana, like, if you educate a man, you educate an individual. If you educate a woman, you educate a nation. And it's because mothers have such a huge influence in how their children is brought up, how they are educated. And for women to die from extremely preventable reasons that we know how to solve, and it's just really, it's just something that shouldn't exist. And it's obvious that it's preventable because it's not happening to people who have the resources to access care. So cervical cancer shouldn't exist because we know how to deal with it. And I think maternal mortality should not exist as well. Deaths from cervical cancer shouldn't exist.
Yeah. Okay, I'm going to hand over to Paul. And and thank you all so much, Mercy. I look forward to working with you and helping to spread your work. And thank you, McGovern Committee Museum, for making this possible.
Thank you, Esther. You're a brilliant interlocutor. That was just a wonderful discussion.
Great.
Good. So I will hand it to our staff. They're going to put up some comments from Ed Catmull to Michael.
Congratulations, Michael. It's really been amazing to watch the rapid development of machine learning, coupled with the availability of large numbers of massive data sets on the web. And I know this has led to this new superpower for finding patterns and correlations. Companies and governments will provide many services based on these patterns and correlations. And while we can't see many of these patterns because of their sheer size, we also can't see the biases that might be in that data. I know that company decisions and governmental policies will be affected by the information gleaned, which will be helpful in many circumstances. But at the same time, we must remember that one of the oldest sayings in computer science is garbage in, garbage out. And the work that you and your colleagues are doing is truly vital to help us get better results in this process and move us forward towards a more fair and just society. I'm very interested in the jury-based approach that you're pursuing and how it can help us as this train barrels forward. So any understanding that you can add to this, for me, is wonderful and fulfills what we want in a Changemaker. Thank you.
Great. And Ed unfortunately couldn't be here with us live today, so I'm the second string who's going to start the conversation here with Michael. And Michael, I want to get around to a question of how you got the original idea to apply the jury metaphor here, because I think it's a fascinating question, the history of science, of how we come up with these things. But there's just a really key question right up front. Everybody is in the zeitgeist at the moment very anxious about the idea of AI being even more opaque than the already opaque system we have, where people don't know what to trust and not trust. Does a jury-based approach, does that help with that issue? Can it help with that issue?
It's an interesting question. You know, deep learning models themselves are really tough to explain, and it's not clear to me what kind of advances we can and can't make on that account. At the same time, one benefit of a kind of jury-based approach is that the metaphor implies some layer of interpretability, even if you don't know why the decisions are being made at an individual juror level. It makes sense to be able to ask, well, how many jurors were for this or against it? Or were there differences amongst populations in who felt this way versus that way? And I think those are questions that are much more natural to be asking, and I think are much more actionable, frankly, than questions like, why did this particular decision, what feature got activated at what layer in the network? That doesn't make nearly as much sense to me. And I think it's much harder to be an activist around that. I think one of the useful things about this kind of metaphor is that by being explicit about the jury composition, you're essentially putting your values on the table. And I think that that's a thing that we've kind of hid behind too long, is like, oh yeah, there's data, it's ground truth, it's correct, of course it must be, it's data. And that's just not true. It's like, who are you asking for? There's some great work at IBM and elsewhere showing that, I think I saw a question that people can be influenced by who's asking for the data, and they sort of try to help whoever those people are. I think what we need to be doing is asking maybe a little bit less around how the model works and a little bit more around, model cards, data, data sheets, these kinds of questions around, where's this coming from? Who's it representing? Whose voice is being represented? And I think that there are huge opportunities there.
It's fascinating. I also think of the history of the notion of juries, and it carries some interesting history. The reason why there were 12 jurors originally was this was submitting in English legal theory to a divine result. And the earliest function of juries was not even finding of fact. It was, 12 yeomen, strong and true, to vouch for you. Basically come in and say, yeah, that person is okay, or no, they should be hung. So there's a whole rich history in all of that. But a key thread through all of history of legal juries is selection. Mm-hmm. And there were a lot of questions coming in as we're talking, is how does that selection process look?
Sure. So if you want to ask me how I would recommend doing it, yeah. I think that what's useful again here is that it's something we can debate, and this opens the door to participatory democratic processes. So there are all number of social choice algorithms and other kinds of things that even just straight up voting, to identify who are the stakeholders who should be represented and in what proportion. And I think that if we, before this, we couldn't even really very easily ask that question. But that's my recommendation. I suspect not everyone's going to want to do that, but some communities, at the very least, I think should be, publishing the jury specification, so to speak. So, we're not saying this individual and that individual. We're saying this many people from this group, this many people from that group, and so on. And I think if that's published, then if it doesn't represent the community, then there's good reason to push back and to change that specification. So I think that's sort of a bipartite answer here, right? You've got a means for collective decision making now. There's a lever, and there's also, by making it public, an opportunity to look at, negotiate, and really self-determine.
Yeah. Well, and if I may, I sort of in honor of Ed, because I know if he was here, he would be going way deep into the technology of all of this.
Sure.
And, it borders on malpractice per se for me to do so. But I think back to those of us of a certain age remember a time before recommender systems, and just culturally what a shock it sent through the publishing industry when Amazon gasps, said, we'll actually let readers do reviews. And everybody was clutching their pearls going, oh no, this is not possible that ordinary people can do it. And then now today, recommender systems are just absolutely the norm, so much so that everybody's gotten really good at gaming the systems. How much of a break from the history and the ongoing evolution of recommender systems, and I'm thinking of Amazon's collaborative filtering algorithms, which I think are just almost 20 years old now. Mm-hmm. How much of a break from all of that is your work?
Sure. Well, I would say what's surprising about our work is that we didn't set out to have anything to do with recommender systems, and it turned out that taking some notional inspiration from that was helpful. At the high level, what's actually important here is giving everyone a voice. So you have a bunch of people who are not physically present, but you want them to be present and have voice in the decision. Well, how do you do that? And really what you need to do is have a model of every individual who's supposed to have voice. You'd be like, well, we have this, it's sort of this almost direct democracy, right? You want everyone to be able to contribute to the decision, and you don't have labels for every single individual. So it's sort of like inverting the entire question around recommender systems, where the point around a recommender system was trying to give me better recommendations, like what movie should I watch? But underneath it is actually just something that says, well, can I predict based on what other people have done, what this individual would do? And the interesting space is at sort of the technical level for us is that these algorithms have been very good at, especially sort of closed sets like movies. We train and then we can deploy on it. Here, all of a sudden, we're getting inputs that the world has never seen. Someone says something and we have to decide, what are we doing about this? So we have to hybridize kind of these content-based collaborative filtering with all sorts of like learning from each other. We need to ensure that we're not borrowing the wrong information, right? So you don't want to, for example, borrow information from a different group when it would be inappropriate, right? If you don't want to have like Beatles lovers' opinions, if I were to just go with the collaborative filtering metaphor, infiltrating what I would think of Adele or something like this, if that's the incorrect inference to be making. So it sort of ends up stumbling back on some of the same goals and infrastructures, but we ended up essentially needing to reconsider some of the basic assumptions of these algorithms to make it actually work.
Sure. What about, one of the challenges that has, of course, been pointed out about machine learning and then other fields like genetic algorithms and like is audit trail to understand how a conclusion was reached. Yeah. Does the system you contemplate have in effect an audit trail? If someone wants to say, well, how did we get to that point?
Sure. So the sense-making system that we're developing around this
you could just make it straight up a classifier, but we think it's important to kind of surround this with visualization and other tools that help people do exactly what you're saying. So one important question that we felt we needed to make front and center was, could this have gone another way? In an in-person jury, you hear the case and there's a vote and that's it. Here we could basically say, well, what if we have all these different juries, right? These 12 we selected, how many of them would have decided this way versus that way, all according to the same specification? Like how certain was this outcome across all the universe of juries there might have been? Who was in favor? Who was against? What were similar kinds of elements in the training data that sort of influenced, so to speak, each of these jurors' opinions most strongly? So all of this information can help you kind of make some sense of what's going on. And you want to do this before you would deploy this. You imagine putting it into sort of like a soft launch where you can sort of observe what it's doing and understand it and reflect and iterate before it actually goes live.
Nice. Let's bring Mercy back in here too, because I got a question for both of you. So you're both doing extraordinary work at a moment in time where, because of events over the last 2 years and gosh knows what else, there is rising public unease about science. We're questioning, the Enlightenment, and just this morning I got yet another very deep, thoughtful email from a philosopher, and it's like, we're getting kind of close to seeing, like scenes in the movie of Frankenstein's monster of people with flaming torches marching up to the scientific castle saying, we actually don't like what y'all are doing. And in both cases, your work has really important applications for the future of humanity, but there are aspects of it that are kind of scary. I mean, Michael, you're using AI. That does not make people comfortable. Mercy, you're aggregating data and making it available to doctors and the like. What would you say to a skeptic who says, well, this all sounds great, but I don't trust what you're doing? Maybe Mercy, you want to go first, or?
Sure, yeah, that's really thought-provoking, and it's not something that's new to the work we are in. A lot of women who we've spoken to in the US don't trust the health system for their care, and for good reason, for historical reasons, especially minority women. And I think, and also even people that we've spoken to in Ghana about our app, of course, their top concerns is security. What's my data being used for? And I think it's very important to stress collaboration with the people whose data you're going to be using, or who are going to be using your tools, because science and engineering shouldn't be done in a silo. I think it should really involve the people who are going to be the end users as stakeholders, right? Maybe that's a small way that it could be addressed, but it's definitely a big challenge, and I'm not completely sure.
Good. Michael?
Yeah, so to someone who is critical of the deployment of computing and AI in society, I'd say wonderful. Like the last 5 years, 10 years have taught us something. And I think ultimately what the question we need to ask is, where are the right places to deploy what kind of insight? Right? We can design our own environments and our own societies and our own institutions. So where should AI be headed? Where should AI be deployed, but only under human oversight? Where should AI be deployed with human oversight? With whose oversight? I think all of these are the right questions to be asking. I think that it's, we need to, just like it was it's problematic to say, well, we're just, of course, going to deploy the thing, the AI, and it's going to work and no problems. It's also, I think, we have to acknowledge what are the productive roles that technology can play and where does it start to really skate on thin ice. And there's no easy answers there. This is where we as computer scientists have to reach out to the social sciences, ethicists, and others to really start to be humble, right? Collaborate, be humble.
Yeah. Well, I want to come back to you on that because I have a specific question about how we give everyone a voice. But Mercy, I want to go back to you with another question. And I look at the platform you're building and also the speculum innovation. And when I think about the common ground between the two of them, it seems like the logical next phase for the community that you're serving, the underserved, is going to come out of the sensor revolution. I mean, the speculum itself is possible because we have low cost cameras and the like, and you've got AI for interpretation. As you look at the arrival of sensors, and I think of sensors in medicine as being revolutionary because, of course, if depending on how you use them, you can shift medicine from episodic measurement to continuous measurement. The Silicon Valley geeks with Apple iWatches constantly monitoring their BP and the like. Where's the low-hanging fruit? Where are the opportunities with cheap sensors that you see will build on what you're already starting?
Do you mean new cheap sensors or what already exists?
Well, I mean, they're deploying what already exists. We've got inexpensive MEMS devices and the like, but in addition, are there other things over the horizon? But mainly, how can you exploit these cheap sensors into your systems today?
Yeah, I think sensors and getting data through sensors is definitely one of the big ways people are exploring combination of health and AI. And diabetes measurements uses sensors, and that's making those cheaper, more accessible, easier to get to people so they can track their sugar levels is, I think, something that should be low hanging. Sensors for something that you could test in your blood and check whether you had this type of cancer. I don't know if we can get there, but that would be really great to have. I don't think that's a low-hanging fruit, probably needs a lot of research. And then cardiovascular sensors to measure cardiovascular health do exist, but putting them in a package that is accessible to people, that can easily be used and integrated into our platform is something that we also want to take advantage of. So long term, we want to take advantage of what already exists, like these ways of measuring like VO2 max or your cardiac health or your diabetes health, make them cheap enough or source out really cheap versions that still work well and that can be made accessible and have that integrated with the platform, because that provides a lot of information and data that the patient doesn't have to enter. But I also kind of wanted to go back to the issue of trust you had mentioned and talk about one of the things in the US. I think a year ago or something, there was a huge scandal about how patients' data was being released for some project, I think Project Nightingale, without permissions. And what I've seen in my work is it's very hard to get data for machine learning because of, you have to go through the HIPAA compliance phase. But the interesting thing is patients are not actually giving you permission to use their data. It's the hospitals and institutions and doctors that are giving you permission. So how do we actually turn that around so that it's not up to the institutions, it's up to me as a patient to have ownership of my data and say, yes, Michael can use it for his AI project, rather than have an institution do that.
That's really interesting. And it is a moment in history where it is actually encouraging that we're seeing the medical and biotech field begin to make amends for the use of historic data in some instances. Clearly have a long way to go. But this ties perfectly with the question I've been dying to ask Michael. And it goes to both of your projects. And that's the question of voice. Who has the voice? Who deserves to have a voice? And in your case, Michael, you've said you want to give everyone a voice. But what's interesting is, as we all know, sometimes the people with the biggest voices on the web today are the ones who are least qualified to speak and have taken the least time to understand it. As you're thinking about that, you know, and also it's like there's so many problems that are intensely important for a small number of people. Like if I'm an individual using your system, Mercy, and I've got a suspected disease condition, I'm going to be deeply, deeply focused on that issue. And then there's the larger community, they may not even think about it. In the jury system, Michael, isn't that sort of the same, that there's a whole ocean of people who might have a mild opinion about something and a small number of people who have a really strong opinion? And in the jury system approach, how do you account for that?
Sure. Well, I mean, this is really a question, as you say, of who is selected, right? Who are you saying is having a voice in this context? There are some contexts in which we as a society have decided to essentially ask a set of experts. So this might happen in medical scenarios. We're seeing lots of things around like the FDA recently, or Facebook's oversight board. We can contest exactly how they picked and who they picked, but they're generally looking for people who look at human rights and on online free speech and these kinds of questions. And then there are other scenarios in which what you want is a sort of one person, one vote. I'm personally most interested in scenarios where there are underrepresented groups whose voices we want to give a louder voice to. And this is what we saw in our early deployments of the system, is that even simply asking, well, who should have a voice here, ended up dramatically diversifying the set of voices, out of proportion perhaps with the set of people in the space, but more in proportion with what your ethical notions of who should be having a voice in this space is, who's impacted, right? And that's, I think, the right way to think about it.
Nice. And Mercy, I'm going to ask you one more question, and I'm going to be really unfair because you're only going to get about a minute to answer it before I give you both the last question, which you know. As I'm listening to Michael talk about voice, and I'm thinking about your health system, an overlooked part of the health system are community practitioners, cultural paraprofessionals, and how do they fit in with your system? I assume that they're deeply engaged and supportive.
Yes, that's who we have in mind when we are developing the systems, both for Color Health and for Gap Health. A lot of devices work in mind that this is going to be used in a hospital with all these facilities, with all these trained doctors. And for the colorscope and pocket colposcopes, which are for cervical cancer screening, we really created them with the intention that it will shift the burden from clinicians, especially in cases where there's not enough doctors, to midwives and community health workers who can go around, door to door, doing community-based screenings, and that way reaching more people. And that's something that we've actually implemented in Peru pretty well with mobile clinics. And even with Gap Health, a lot of telehealth focuses on doctors again, but we know that community health workers are more represented in a lot of sub-Saharan Africa regions. So we want to include them in being verified and using the platform, as well as nurses.
That, to me, that sounds like one of the most exciting possibilities, because the community health workers are obviously such a force amplifier in promoting public health. And it's easy to imagine a future when we have, all sorts of affordable devices that they can carry and the like. So we're up against our time limit, and it's so frustrating because we could go another hour or two on this. I want to read you all know the final question. You've been thinking about it, and I want to read it to our guests in the audience so they understand what you're about to answer. And that is, as part of CHM's One Word initiative, you are asked to write down one word of advice for a young person starting out in their career. Can you share that one word and the story behind why you chose it? And Michael, I'm going to start with you and let Mercy have the last one word.
Oh, now I'm not prepared. Okay, so my one word is people. So here's where I come from. As I kind of came to design and technology, the notion that we'd be designing around people was surprising at best and problematic at worst. And a number of individuals who I count as my own inspirations, mentors, and so on, really blazed a path by articulating that technology is ultimately for people and designed in the service of people and designed collaboratively with people. And so for me, when we're saying to a computer history museum, what's the watchword? I think it's people. I think it's that we engage in that human-centered process, that we are reflective of our positions as people in societies, in nations, and in the world.
Lovely. Mercy, you have the last word.
Mine is, I don't know if you can see it. Oh.
You can't hold it back a little bit back. Just, oh, Aya. There we go. Yes.
And what I've drawn next to it is a fen. Aya means a fen, and the story behind it is I tried to pick an Adinkra symbol, which is symbols that the Ghanaian culture that reflects wisdom. And Aya fen actually stands for two words, even though it's one. It's for endurance and resourcefulness. And for me, I think for young people starting in their careers at any stage, it's really important to be passionate, but accompany that with being enduring and working with whatever you have, working with the little that you have. The interesting thing about the fern is that they blossom and rise out of adversity. So the spores are released in dry environments, which are typically adverse for the plant, and then carried away to better places for them to grow. And so this, I think, is really reflective of, I guess, the blurry background doesn't help me, but it's really reflective of where I think young people starting in their career should look to. And also just in the limitations and difficulties that have been mentioned today regarding AI, it seems like we have a long way to go, but with endurance and resourcefulness, I believe we can get there. Thank you.
Oh, thank you. And what a beautiful metaphor. And thanks to both of you for absolutely perfect words. I've got another 3 hours of questions, so I'll call you separately. But this has been, insightful and mind expanding and a validation of why you so richly deserve these awards. And with that, I'm going to hand it to Daniel to take us out.
Thank you so much, Paul. And thanks to the entire team, the CHM team, the McGovern Foundation, the selection committee, the Changemakers on the program today. This was a wonderful program. And thanks to you, Paul, for moderating it so nicely and eloquently. I think that Mercy and Michael are representative, absolutely representative of the notion of a changemaker in honor of Patrick J. McGovern. And why do I say this? I think that the reality is that this whole program is about a journey. And the journey is about the human condition. As we embarked upon this effort with the McGovern Foundation some couple of years ago in conversation, we were in the process of evolving the mission of this institution to focus on people. I think Michael nailed it personally. In the beginning, people were computers, and we invented computers as we know them. And as a result of that, the world is really not binary, it's analog. And as Patrick earlier in the program described his father, Patrick J. McGovern, he eloquently described that Pat was a global citizen. For those who knew him and know of his legacy, Pat visited every one of his subsidiaries every year around the world personally. He hired locally in each country, did not plant expatriates around the world. He literally invested in the local human condition. And his legacy, Lori McGovern, trustee at the museum, and Pat put together a fundamental institute at MIT thinking about the brain science and the human condition. So it couldn't have been better served today by this program and the two Changemakers in this inaugural effort to honor Patrick J. McGovern. So with that, I'd like to thank those who participated, everyone who contributed, and encourage those who are capable and willing to support the museum so we can continue these wonderful programs. So again, thanks to you all. Enjoy the rest of your day. And with much appreciation, I sign off. Thanks so much.